I've got to get my recording started,
Okay, absolutely.
and I'm good.
All righty. So I'm not somebody that just reads studies, uh, goes on Wikipedia and say and look stuff up. There's a lot of people that go to Dr. Google and call themselves researchers, but I'm actually the guy that supplies the product. There's not a kilo of our product that goes out into the marketplace that I don't thoroughly inspect and got the certificates of analysis, all the different things. When I first started, and Dr. Daly will remember this, certificates of analysis 35 years ago might be on an ingredient like this. Well, it's an off white powder, a little bit of a yeasty smell, maybe, and is mostly solids. And that might have been the C of A back in the early 90s. Now we've got like 2 or 3 pages of documentation to go into all the details of not only what we tested, but how it's tested. So I'm worried that if I ever send out a kilo of this material and it doesn't work, there won't be any place I can hide. I mean, I can't go be a bricklayer or something like that. But Jonathan, let's go to the next slide. Uh, $120,000 a kilo. When I first started chasing where is beta glucan right now, that was the price of the material. There's actually a company called Sigma Aldrich, and all your scientists, all your universities, all your top people that do work go to Sigma Aldrich to get their ingredients to calibrate their equipment, their standards, if you please. And Sigma Aldrich has an ingredient, G is in George, 5011. G5011. And back then, a 100 milligram portion was, I want to say, somewhere around $900. Today, I think that price is like $1,200, $1,500, $1,600. Price of gasoline, price of shipping and handling. Man's got to eat. But 100 milligram, when I looked at that, I said, wow. I said, if I had to depend on something like this for my friends, they just have to die because no way they can afford these things at that price. And I'm not the guy that invented this material. In fact, it started back in the 40s, but I met a guy by the name of Michael Cato. He's still alive up in Spartanburg, South Carolina. And Michael came up with a process where we could manufacture this material at a high purity so that the glucan content also was very, very high. And the price for the average person who's, say, 100 to 200 pounds would be, I don't know, $1 a day, maybe a little over $1 a day. Again, stamps have gone up. So before I go too deep into this, Jonathan, let's go to the next slide. I want to get into the fact that the source of this material, not just the source where you would get it from daily manufacturing, but also the source where the material itself is processed from. You can go to the grocery store and buy a little pack of Fleischmann's yeast or Red Star yeast and whatnot, and that's basically what the material starts with. It comes from the cell wall of what you would know as baker's yeast. Now, we need to know that it's Saccharomyces cerevisiae, but we actually have a proprietary strain because we want to make sure that if our manufacturing process is good and tight, that we can get a relatively good response to that process and not waste so much material. Well, we don't do that good all the time. In fact, over 90% of the material that's manufactured using the process is rejected. It does not meet or exceed my minimum spec. But I want to talk a little bit about the immune system first because uh, we don't want the FDA to suggest that we are curing or preventing or mitigating, even though I'll be teaching directly from the public literature and these journals. But I think it's important that you understand a little bit about your immune system and why it would be prudent for you to consider this material. The immune system has two arms. Those two arms, one represents the innate immune system. This is the immune system you were born with. And when something comes along that is not self, not you, it goes to work in minutes, a couple of hours. It's broad in its response, it's non-specific. It doesn't matter if it's a virus, a bacteria, mold, mildew, parasite, or a cancer cell. Non-specificity, that's a big part of the innate immune response. You've got a group of cells, your macrophages or macrophages, depending on which side of the Atlantic you're educated, neutrophils, NK cells, natural killers, your dendritic cells. These are examples of some of the cells that fall under the umbrella of the innate immune system. They are your first responders, and they don't need to have seen whatever it is prior to. They simply need to say, is it self? And if it's not self, then they will respond, they will attack it, they will eliminate it, and get it out of the body. Memory, back, not dating Dr. Jimmy, when he went to school, when I went to school, that side of the immune system, you didn't talk about memory. It was one and done. It responded, then it went back to a state of rest. That was your uh, that was your innate immune response. On the other side, the other arm of your immune system is called the adaptive, or I sometimes call it the learned or the learned side of the immune system. Now, that didn't crank up in a couple hours. In fact, it could take days, even weeks, to reach a level to be very effective. It's also very specific. Specificity is a big deal on this. If you are rub up against a dog and that dog has a certain amount of fleas on it, and that flea bites you and it has some sort of bacteria or virus, that's not necessarily going to help you if a mosquito bites you and is carrying a different kind of bug. So you can take different compounds, you can take vaccines and so forth to give you a prior look see at some of these compounds, some of these targets, so that your immune system, primarily through the production of antibodies, will be ready if it ever shows up again. So again, it's a targeted response. It requires prior exposure and it gives you memory. Now, a couple of us on this call, I had measles before there was such a thing as a measles vaccine. In fact, I had a bad case of it, almost didn't make it. And later on, there was a measles vaccine that came out. It was pretty good, not so great, maybe, 99, 95%. Now, the second round at that vaccine did a lot better. And I believe if you get the vaccine and you get the booster, you're hitting up in there around that 95, 96, 97 plus range. I know it changes a little bit based on experience, but these are some. But down at the bottom we talk about beta glucan. It works directly on the innate side. Again, those macrophages, neutrophils, NK cells, dendritic cells. This is important because by activating or readying that system and it responds first already, it's going to do a better job. Jonathan, next slide, please. So meet the macrophage. Now, that picture is clearly not an immune cell. We're showing you the surface because we talk so much about the receptors, the little stick ups there that you see. There's a dectin 1, a CR3, stands for complement receptor number 3. There's several complement receptors. And then your toll like receptors, there's a handful of those. And this diagram is showing you the way that this product and the molecule works once it gets to these receptors. Now, dectin 1, and you see the molecule stretched over it, uh, think of that as like a handshake, okay? You've got really good firm handshakes where, the tips of the fingers start changing color. You've got kind of those limp, dead fish type handshakes, and then you got fist bumps. Some are better than others as far as making contact. One of the things we know is that the yeast particle, and that's actually what our powder is made of, insoluble particles are the best to bind to the dectin 1 receptor. Okay? Then we move over to mushrooms. Now, I don't want you to feel like I'm down on mushrooms. I like mushrooms on my steak. Uh, Dr. Jimmy, you probably eat mushrooms on your mushroom burgers, right? Are you a big mushroom fanatic? So these different compounds have very similar molecular structures in that we have a 1,3 backbone, these long, almost think about it like a long set of pearls, and the pearls are hooked together 1 to 3, 1 to 3, 1 to 3 as these six-sided, six-cornered molecules are bound. And then ever so many terminals, there's a 1/6 side chain. Now, the frequency of those side chains, and then the amount or the length of 1,3 short chains on the side of those influence how well they bind to that receptor. Imagine you got a catcher's mitt and you got a golf ball. Well, that really doesn't bind too well to that catcher's mitt. So you got to have a ball that fits nicely that catcher's mitt can capture and hold on to. That's the important thing. Now we get on to euglena. Euglena and also euglena kind of sits in a group by itself. Some say, well, what's euglena? I never heard of it. Well, I affectionately refer to it as pond scum. Okay, so it's great stuff, but it only has the 1,3 backbone. It has no side chains. So of these three, they probably do the least good job of binding to that dectin 1 receptor. Now, why is the binding so important? Well, as soon as you've got a good binding, then you've got other dectin 1 receptors on the cell start migrating to that area. They get concentrated, and this starts giving you the phagocytic synapse where the tentacles are reaching out and doing a really good job. It's not that the mushrooms don't do it. It's not that the euglena don't do it. It really has to do with how much does it take. Do you have to take 4 times the dose, 8 times the dose, 16 times? How much do you have to take to get the same response? Let's go ahead to the next one. Now, I don't want to get too far up into the tall weeds, but Jonathan's got a copy of this, so anybody that wants to go back and review this. So I'm going to walk you through. You've got the beta glucan binds to that carbohydrate recognition domain. That's your dectin 1, okay? The dectin 1 then causes other dectin 1s to migrate to that area and activates that phagocytic response. Now we start getting into the inside of the cell. Sick is it's an enzyme. It's an important enzyme. It's a master switch that causes the changing of certain chemicals that then go downstream to card 9. Card 9 is, think of it like a protein scaffolding. Okay. Then from there, we go to NF kappa B. Now, NF kappa B now, it's actually now entering into the nucleus of the immune cell. And there it is making messages to cause that cell to secrete cytokines, tumor necrosis factor, interleukin 6, interleukin 1, interleukin 12, interleukin 2, all these different things. I refer to these cytokines as like chemical fax messages and emails. And they travel all over the body, communicating to other immune cells, causing them to be aware, hey, something's going on over here. And then they get into the process of doing what they're supposed to do. Now, I want to come back to the master switch. The master switch is really important because once that is activated, you're actually talking about 6 different branching pathways. And this all depends on this single kinase activation. And a lot of work is being done, has been done, and continues to be done. Really getting down into the nitty gritty. There are several groups that are trying to figure out how can we get this approved as a drug. Well, I'm not going to hold my breath. It's going to be a while, but understand that this one receptor event triggers a coordinated immune response across multiple pathways, as Joy Zopp with Harvard once said, setting off a cascade of immunological events. Next one, please, Jonathan. Okay, not all beta glucans are equal. Now, what I've tried to do here is give you a cross section of the yeast cell. And so we slice it apart. It is a living cell, so it's got all the mitochondria and the nucleus and all the different parts necessary for it to do its job. Well, a lot of its job is making more yeast cells. So you see that budding up there at the 1 o'clock position. And that's how these cells multiply, by budding, and then they break apart. Now, in the box to the right, you see a blow up of the cell wall. You'll see the amount of protein covering the yeast cell. And then below there, you've got this complex array of the 1,3 and 1,6 glucans winding back and forth. And then you actually see down there a spot where chitin we know in nature to be the exoskeleton of things like shrimp and crab and roaches and grasshoppers. They also are parts of the carbohydrate kingdom. So when we talk about glucans, we're really not talking about one thing. Glucans are actually a family of different molecules. Again, going back to the source. Is it coming from yeast, from mushroom, maybe cereal grains? Every time the little Cheerios girl comes running out, talking about lowering cholesterol and so forth, our sales go up. Okay, got nothing to do with grain glucans, but our sales go up. And then, of course, the euglena. There are other places. In fact, glucans are widely found out in nature, usually in the lower plants. You'll find it in certain bacteria and whatnot. And the great thing about it is living organisms, it doesn't make any difference if it's shrimp, whether it's earthworms, uh, mice, rats, rabbits, dogs, cats, you name it, they all respond to this message. See, I didn't pick beta glucan. The immune system chose beta glucan. It chose it based upon these receptors that we're talking about. Okay, next one, please, Jonathan. So, a poor attempt. I didn't want to get too fancy with it, but on the left, you will see the basic central chain that represents the 1,3 backbone. And then you see the 1,6 side chains, which actually have some dangling 1,3s off the edge of those. This is what we're talking about when we talk about our ingredient. And this is this is the structure, this is the conformation that binds that dectin 1 so strongly. On the right, this could be oats, barley, could be the euglena. The euglena doesn't have any side chains, and I didn't want to draw side chains on this because it would get. But they're linear. They're much straighter, and they're water soluble. So this again goes to glucans are not very descriptive. They really don't narrow down what you got in the bottle. So across the bottom, you see the different sources, whether it's yeast, mushrooms, or your grains, the type structure, whether it's heavily branched, variable branching, or just straight linear. And then dectin 1 responds very strong to that yeast 1,316. The mushroom, more inconsistent, minimal, if any, with your grain glucans. CR3, this is a second receptor. We'll get into that more in a second, where again, good, strong binding. You've got variable binding with the mushroom, and again, your grains, not so much. So, from a clinical standpoint, when we're talking about, hey, I'm going to have my mom, I'm going to have my dad, I'm going to have my brother, my sister, my children using it. If you want the best in immune signaling, well, you're going to use, our yeast source material. Mushroom, again, it's not going to work, but it's more of a gamble about not if it works, but how much you have to take, and it'll vary quite a bit from lot to lot. If you want something to lower your cholesterol, if you want something to help you with blood sugar, these types of metabolic disorders, load up on your oats and barley glucans. You can get a big bowl of them, eat them every day. That's a good thing. But if it doesn't have that 1,316 branching, it's not going to be a reliable trigger for your immune response and immune signaling that we described earlier. Next one, please, Jonathan. Now, mushrooms, boy, they've been around for thousands of years. Uh, Soups, sandwiches. As long as there's been something written down in the Far East, Dr. Daly goes over on a regular basis. I guarantee you he's exposed to a lot of mushrooms while he's over there. There's been not one, but 3 different oncology drugs that have been approved in that area of the world. Now, I talk mostly about PSK Crestin. PSK Crestin. The reason I talk about it the most is because it's the one that can be orally dosed. Hence, it's more applicable to our orally dosed product. The others, they're IV infused. Again, they're good, but they do not replace whatever standard of care. but they are excellent. They have people that choose this, and the literature supports it as great adjuvants. Now, let's zero again in on the PSK. You've got actually two active components. With the mushrooms, you've got a protein bound compound. In other words, you can't purify it so much that you end up with just a pure glucan or a pure carbohydrate because the way the protein is bound to it. Okay. Now in 2015, they started zeroing in because again, 30 years ago, a lot was known, but not nearly as much as what I mean, we've got better technology. We've got better people running the technology. We know what we're looking at. We know what we're looking for, and we can repeat the experiment and get the same thing over and over and over again. So what they're saying is not so much Dectin 1 and maybe the toll-like receptor number 2. In other words, they're saying that this lipid that's also attached to the PSK material is part of why it gives the immune response that it does. Now, I'm not going to go that deeply into this, but again, as science advances, we find out more and more. Now, here's for some of you, it may be a secret. Some of you may be aware of it. You know, it's hidden right out in plain sight. Here in America, nobody's selling one of these three compounds. One of these three compounds that are manufactured so exquisitely that they actually passed muster and was approved as cancer drugs. That's not what's being sold here. So you've got companies that are selling the mushroom, let's say body and fruit, and then you've got another group, and I'm painting with a broad brush, two groups. The other group, not only do they take and grind up the fruit in the body, but also the mycelium, the roots that grow down into whatever they're growing it in, the substrate. It could be oats, it could be rice. I did some work up at North Carolina North Carolina A&T State University a number of years back, and one of the researchers up there was doing a lot of work with mushroom because the Golden Leaf Society up there had all these gazillions of dollars that they were holding from where the tobacco companies had been sued, and that money was being doled out to try to help some of these smaller farmers. You know, what else can they grow? And so they were looking at mushroom amongst other things. And what he did was he crushed up newspapers into columns and put chicken wire around it, many columns in the room where they would control the temperature and the humidity, and then impregnate, just shoot the spores in there, and out pop mushrooms. They were doing a beautiful job. Why? Because what's paper? Paper's made out of cellulose. So this would be an example then of the substrate. And no, the professor, he didn't grind up the newspaper and put it in a pill, but a lot of the product is sold, again, not with just the fruit, the body, but also the mycelium and whatever's hooked. And some of the folks, they don't hide it. They talk about how great it is, how natural, this mix is with the substrate. But it's, when you grind up all of that together and put it in a pill and say this is beta glucan, from where I stand, that's being a little economical with the truth. So the content that's in a lot of these mushroom compounds are not just mushroom. It's mushroom plus the growing medium. Next slide, please, Jonathan. So what I started doing back in the early 90s working closely with Dr. Vaslav Vetvika, Dr. Gordon Ross, Dr. June Yan, all at the University of Louisville, other researchers in the field. And I said, look, but which, by the way, they had already been working with glucans for a long period of time. There was an argument for a long time that unless you had a water soluble for injectable, stick it directly into the vein, into the tissue, whatever, that this insoluble particle could not make it. Well, that was actually proven to be incorrect. In fact, Dr. Gary Ostroff, who worked with Alpha Beta Technologies. We worked together at a company up in Eagan, Minnesota, and his work had been with a company called Alpha Beta Technologies, and he was charged with proving once and for all will these insoluble particles actually go through the gut wall. Well, they actually demonstrated. Not only did they demonstrate it, but they took material and they put a special dye on it, fed it to rats. I never say mice because some people don't want you killing mice. And they sacrificed the animals every so many days, and they found after 3 days these nice, neat, round little balls inside the phagocytes, inside the macrophages. Well, that's basically what's in our capsule, these little particles. And then 5 days later, we saw the particles start to break apart. And then a couple of days later, we started seeing just an aggregation around the lining. And then a few days later, they were gone. But what we saw in the meantime is that these cells were, as they were breaking them down, the particles, they were secreting some of the particles, much smaller, and they also were secreting the water soluble molecules. This allowed then the other receptors, like your complement receptor 3, your toll like receptors, all of these receptors could all be activated. So I put up just a couple of the studies where multiples of not just glucans, but other compounds were tested side by side and said, okay, how do they respond? And you see there to the right, measuring IL-2, which again is a pretty important interleukin that particularly in the area of cancer, shows that not only are we activating on the innate side, but these signaling processes are going to other cells. I believe those are splenocytes producing the IL-2. Next slide, please, Jonathan. I want to drop back a little bit and talk about the certificate of analysis. The certificates of analysis have expanded over the years, mostly at the behest of the FDA. And we use what's called the GEM assay. GEM stands for Glucan Enzymatic Method. Now, that actually was developed in the laboratories up there in Eagan by a couple of chemists and biochemists that work for Alpha Beta Technologies. And Andy McGee and several others put this together. And the essence of how GEM works is they take a very powerful sodium hydroxide, and this is an alkaline compound that makes the yeast cell wall swell up. Because if you don't make it swell up, then you cannot get the important enzymes inside to digest away the 1,3 and the 1,6 linkages. And those are the only two things that these particular enzymes work on. And so they get the amount of the total weight, and then they say, okay, we're going to go through this process. We're going to get rid of the 1,3. We're going to get rid of the 1,6. weigh it again. Well, the difference is how much 1316 glucan is there. Now, there are other forms. Megazyme's been around a long time. They do a great job advertising. I think they were first developed in Ireland, if I'm not mistaken, somewhere over in the UK. Their claim to fame came with processing and measuring the glucans in cereal grains, and they do a real good job with that. But that's a different molecular structure. 1314. It's linear. It's water soluble. It's a whole different thing. It's like I don't know how a unicycle versus a, a bicycle with training wheels. I mean, it's yes, they're all glucans, but glucan again is a big family. Now, depending on the different types, and you've got some very famous companies. You've got Eurofins, you've got Kyr. There's many companies out there that will do a beta glucan analysis. Uh, Dr. Daly maybe remembers when I sent. Actually, I think I got Dr. Daly to send. We had one lot of beta glucan, and he chopped it up into three different bags, sent it down to University of Georgia Complex Carbohydrate Research Center, and they spent weeks doing what they did, and they came back with three drastically different results with their assays, which told me it's not that easy. And so, again, this gave rise to other forms of assay, enzymatic methods being one, and then we eventually evolved into the GM assay, which is not an easy assay. It's tough to get it to come out. So that's why you do it. You measure twice, you cut once. Well, we measure at least three times before we give a number. Next slide, please. Okay. Now, what does the research really show? And I'm going to start now. We're leaving the test tube, we're leaving the rats and the mice, and we're getting into really grounded, published evidence on what it does for us, the human beings. Next one, please, Jonathan. When I first started, largely because again the mushroom data very, very compelling. Reduced metastasis, reduced size of tumor. Some, cancers, I don't want to use the term cured, but they already had years and years of what the results were if they're using chemo, radiation, and or surgery. So they did things a little bit differently. They just said, okay, we're going to put these compounds in like 5,000 hospitals alongside the chemo, the radiation, and see what happens. And there were like, I don't know, hundreds and hundreds of studies showing these incredible results. And that's what really put me on the hunt for this glucan. So again, as time goes forward, there's a tremendous amount of work now and continues to be done on upper respiratory tract infections. And I've listed here just a couple of the leading authors in this area. Zhang, a meta-analysis. That's an analysis of a whole bunch of studies that are out there, and they grind all that data and they say, okay, what do you come out of here? All right, 13 randomized controlled studies pooled together. They showed a 65% reduction in the odds of you getting an upper respiratory tract infection. And if you did, you'd have fewer episodes and a shorter duration. Feldman came back and said, okay, over a 12-week trial, this is one guy, one trial, 0 days from work missed, with the placebo group over that 12 weeks, an average of 1.38 days missed from work. Fuller, again, a guy that's this published multiple of studies, looked at older adults. You have what's called immune senescence, where the immune system tends to wind down over time. And at 250 milligrams a day with 100 people, he found significantly higher levels of gamma interferon. This is, again, one of those important chemicals that, again, you get less and less, and they're so important with viral infection and other ways that the immune system fights. Cano, this year, 100 milligrams, 180 milligrams a day, 39, not a huge number, but increased dendritic cell activation. Dendritic cells, they're like messenger cells that, when the neutrophils and the macrophages are eating, they're kind of sloppy eaters. You ever see anybody walking around, eating a sandwich and they're dropping crumbs all over the floor? Well, those dendritic cells, they'll grab up those crumbs and then fly through the lymph system to the lymph nodes where you've got a lot of resident T cells and show them to the different T cells until finally one of these T cells says, whoa, 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 wait a minute, let me look at that a little bit closer. So now we're seeing the transition and how part of that happens from the innate side over to the learned, or the immune system, where you've got your antibodies, your B cells, and so forth, and you get T helper cells, subset 1, subset 2. Dr. Daly will give you a seminar on all of that, but the bottom line is you've got all of this huge body of evidence. They're all pointing the same direction. Next slide, please. This is a hot one, but it didn't get hot until just a couple of years ago. TRIM, otherwise known as trained immunity. And they're still digging hard into this one. Again, the beta glucan binds. The phagocytic synapse is created. mTORN, HIF1. It shifts the Warburg to a different type of chemicals that are produced and how they're now we're getting into the epigenetic markers, and now we're starting to flip switches inside the actual genes of the immune cells. This is enhancing the readiness of the cells, not memory in the way that you have memory with T cells and B cells, but they respond more, better, and faster the next time because of this ingredient. And get this epigenetic changing travels all the way back into the bone marrow. And this is the factory. This is the factory for all of your white blood cells, red blood cells, platelets. They all start in the bone marrow. And now the factory has been reprogrammed. And there are lots of studies already. They're continuing to get into this. And what this teaches us, again, number one, this doesn't happen now unless you've got that particulate form of glucan teeing up the ball up there at the top. Your solubles, your mushrooms, they don't trigger this pathway. They don't trigger these other responses. So it's a big deal that your innate immune system can be taught differently than the acquired side. But nonetheless, it does a better job when something else comes along. Next slide, please. This is not a minor slide either. Disease tolerance. Disease tolerance. Well, the average person knee-jerk reaction would be, whoa, wait a minute. I don't want my immune system to tolerate disease. I want the immune system to open up a can and whoop that thing and get it on out of here. That is not always the best way. The overstimulation the chronic stimulation, the long-term stimulation, which can happen with a lot of different compounds, is also going to damage the healthy cells. You heard a lot about this, particularly during COVID, because a lot of people were running out trying to find different herbals, different compounds. Give me some more immune response. When a lot of times maybe the people didn't have enough vitamin D. I think some of the earliest work was out of Italy, where a lot of people that were succumbing were vitamin D deficient. Because sun is bad for you. We can't get too much sun. Well, you need to make sure you've got that vitamin D because it's important, zinc and other things. So, what's new about this disease tolerance thing? Again, in this re education of the innate immune system, we're teaching it to fight. Your immune system is still going up against and will conquer the challenge, but it's not going to allow the immune system to go into overdrive and cause self to be damaged. Big deal, disease tolerance. Uh, this was published, by the way, in a very uh, big journal. Nature Immunology is one of the largest and most respected journals out there. They don't publish uh, supplement stories. They don't publish anecdotals. This too is a very big deal. Next slide, please. Okay, cancer immunosurveillance and NK cells. Dr. Daly said, let's hear a little bit about NK cells. Not a problem. Not a problem. Uh, Dr. Vetvika, Dr. Gordon Ross, this was one of the earliest things that they did. Gosh, I want to say back in 1996, where they demonstrated that the use of this ingredient, and this isn't necessarily a paraphrase, this is pretty close to what the study actually talked about, was that it caused natural killer cells to recognize targets that would otherwise be invisible. That's a big deal when it comes to cancer because you hear, well, wait a minute now, cancer starts off as self. And so it's able to evade it. It doesn't come in because you inhaled some cancer cells, because you rubbed up against. Those poor people out there on that cruise that's got hantavirus. They were inhaling maybe rat urine or rat, whatever. Don't ever inhale anything coming off a rat, by the way. It could be very untoward for you. But I don't mean to make light of it, but a very sad situation. Hantavirus is not, again, upper respiratory tract problems. But I want to talk a little bit more about CR3 because this is very, very important. Again, you get the beta glucan molecule binding to CR3. You get complement binding to the target, cancer cells. Bada bing, bada boom. Those NK cells, neutrophils, the cells that have these primed are going to hit, and they're going to hit harder, more times, more repeatedly, more viciously. Vetvika has said many times, is this a cure for cancer? Can't say that. What he did say was, well, if you want your immune cells killing more cancer cells, it would be good for you to use this product. That's what he says. So again, selectively going after tumor, not self. Can't say that with chemo radiation. And again, I'm not trying to advise anybody on what they should or should not do. You need your competent healthcare professional to figure this out. Again, a long track record, 2021, Steinbach, 16 different trials, 1,650 cancer patients. Beta glucan was found to be safe and well tolerated, again, as an adjuvant to chemo and radiation. Big deal here, it reduced the immunosuppression. One of the big things with these types of treatments is they cause the white blood cell counts to crash. Sometimes they can crash so much that they need to give you drugs to try to amp up, try to get the bone marrow to say, send me some more white blood cells. Well, I kind of say, well, wait a minute now. That's a little bit like putting water in your gas tank. Yeah, the needle will go up, but are you getting what you need? And the great thing about this product, has been shown that it produces growth factors. These are important, again, chemical fax messages that your immune cells send to the bone marrow saying, hey, I need some more natural killer cells. I'm running low. I need some more neutrophils. I'm running low. And so these colony stimulating factors and other chemicals, very, very important. So selective tumor targeting, no off target damage to healthy tissue. Very, very important. Next slide, please. Now, one of the most often, if not arguably the most often asked question I get, other than what is beta glucan? Next slide, please, Jonathan. Okay, I'm going to give you information published from clinical trials. Years ago, when Dr. Vetvika started doing his various assays, say a quarter of a milligram per kilo of body weight, or a half a milligram, or a milligram, or 2 milligrams, and so forth, I looked at the dose curve that he was creating with our ingredient, and I said, okay, if we look at about 2 milligrams per kilo of body weight, we don't do a lot of kilos. In fact, I tell you, don't talk about kilos if you're on an airplane flying around in America, because it'll raise a lot of eyebrows. If you weigh 100 pounds, you can take a 100 milligram capsule, and that's going to raise your immune response by about 50% of where it is. Don't know where it is, but it raises the immune response for you based upon that dose. If you weigh about 200, maybe 220 pounds, to get the same immune response, you need to use around 200 milligrams of our material. So that's where I started years ago, and still today. I said, these are good areas for the healthy person who wants to maintain that good health. Now, if you're not healthy, and I tell people, I said, are you healthy? Let me qualify this. That would be like me asking you, are you pregnant? You can't be kind of pregnant. Are you healthy? Are you disease free? You don't take any kind of pharmaceuticals over there? Okay, let's get you using 100 to 200 milligrams based on your body weight. If you're much over that, you might need to go on a diet. All right, so with adults, you look at around 250 to 500 milligrams a day. And if you've got a product that's only, say, 75%, then you're not really delivering 500 milligrams. You only delivering about 375 milligrams. With children, and we've got a handful of double-blinded placebo crossovers. In fact, Dr. Daly did the placebo work, and he filled the capsules that we sent over to Dr. Vetvika and his colleagues to do this work in teaching hospitals over in Europe to get those studies back. Other people have used this material in other studies in China and other places, and the results have been largely the same. The doses, again, for a child, anywhere from 26 to 100 milligrams a day. Now, I'm going to skip over to timing, and I'm going to give you a little secret about this. It's not like I made it up, but after doing this for a while, and I said, well, okay, take this whatever dose, let's say 200 milligrams a day. Can I take it with my coffee? Can I take it with my thyroid medication? Can I take it with my protein shake? Can I take it with whatever, whatever, whatever? All right, we know that the uptake of our ingredient, this insoluble particle now, it goes through the stomach. We don't make the enzymes to be able to digest it. So when it hits the small intestine, you have these Peyer's patches that have M cells. These M cells are just randomly and non-discriminately just tasting stuff, grabbing stuff as it comes through. Now, this is a physical pulling through of these samples into the lining, into these vesicles that are packed with your phagocytes, mostly your macrophages, other cells. But this is the first contact that the immune cells come into with our ingredient. So I typically would say, look, don't stick it in the middle of a double beef Whopper with cheese. Don't stick it in. Don't eat it on top of a 20-ounce porterhouse, because now you've got your 200 milligrams or your 500 milligrams kind of mixed up. Now, I have always told people take it, give or take 20 or 30 minutes before you eat solid food, or best if taken this way. But the truth is, when we do the feeding studies to the rats, we get Purina to mix that chow together, and the rats are eating it. And yes, the rats get a response. But I don't equate that again to the double beef Whopper with cheese or the big. If you want to take it with Jello, if you want to take it with your milkshake, I don't see a lot of competition there. But I just I just think if you're going to buy the material, you want the most juice for the squeeze. Okay. Now, what's the upper limit? For humans, there is no established limit. There's been testing of hundreds and hundreds of milligrams for long periods of time, no ill effects. But in clinical studies, the largest dose over a long period of time is around 900 milligrams. Now, I've had customers use 1,000, 1,500 now for over 20 years. They're still around. It doesn't seem to hurt them. No drug interactions. Okay. Now I'm going to circle back to the loading period. Remember what I told you about trim. Remember I told you that over time, the innate immune system is being trained. When I talk about epigenetic changes, I think about, putting a bookmark, here's where I left off last time. That's kind of what's going on, in that the next time the innate immune system does a better job. Not the same kind of memory as what you've got with the acquired immune system, but it does a better job nonetheless. I've had people say, AJ, this stuff costs, and the price of rice nowadays, whatever. I don't know if I can afford to take it. Here's what I've told them. And again, I'm not trying to give you medical advice. I'm just giving you my experience over the years and my knowledge of how it really works if you use it as directed. It takes about 72 hours from a single dose. If you've never taken the product, it takes about 72 hours for that dose to peak. If you don't take any more product, it's going to take roughly 10 days to go back down to your baseline, whatever your baseline was. So, is it critically important that you take it every single day? Obviously, if you took it every day, then you're going to be able to maintain whatever that level is. But if you skip a day, you've effectively cut your cost by 50%. If you skip 2 days, you've cut your cost by 2/3. I don't think it's going to hurt you, particularly if you go through what we call a loading period, excuse me, where you've had consistent daily use. And this will vary from person to person. What kind of condition are you in? What other kind of drugs? What other kind of things? This epigenetic reprogramming timeline will vary. But after a month or so of using a particular dose, again, as we suggest, you're going to be able to slack off. So again, I would become familiar with trim, how it works. I wouldn't be bashful about spending the money early on, recognizing that after you've been on this dose, and I would say for at least a month or two, if it were my mother, if it were my child, my grandchild, I want to make sure that they're locked into this trim before I tell them to take the foot off the gas. Okay. Next slide, please, Jonathan. Okay. We get more and more medical doctors that are becoming interested in this. And yes, beta glucan is coming from a baker's yeast. Baker's yeast is a fungal form. There's a test called the Fungitel assay. And what that does, somebody who's suspected of having uh, a yeast infection, candida, maybe breathed in, black mold, whatever, they'll run this test and it'll trigger. Why? Because again, all fungal forms have beta glucan in them. However, they're reading a different signal from, see, that's a whole fungal form that has not just the 1,3-glucan, it also has the mannoproteins, it's got the lipids and so forth. So that's a different signal. So if you're taking particularly a relatively higher dose and the doctor tests you and say, oh, wait a minute, you lit up this Fungitel test, then educate them, have them call, and again, there's good literature on this. So people that are, if they're being hospitalized, if they're undergoing surgery, you want your team to disclose, don't be hiding the fact that you've got beta glucan, give them the literature that we can provide them. And the doctor may say, let's back off of it, particularly if it's elective surgery, if possible. And that way, if they're testing and you happen to be exposed, I try not to hang around in hospitals very long. There's some bad stuff in hospitals. But again, I want to emphasize this is not a safety concern, but it's something that I wanted to put out there and be proactive so that you don't worry about explaining it to your doctor. We understand the science involved in this. Next slide, please. All right. Who benefits the most? Again, this is based on the peer-reviewed literature, the various human trials, a lot of work done with athletes, cross-country runners, firefighters. These are people that often, when they come out of an episode, particularly the people that train hard and then they run hard or fight hard, whatever they do, there's a window of opportunity a day or so after this extreme exercise where they're more subject, particularly to viral, the colds, the flus, that kind of stuff. Again, the work's been done on this, 37% fewer colds and flus. Stressed individuals. I've got some young friends, they're in all different, business school here at the University of South Carolina, and they're taking statistics for the first time, and they're worrying about their GPA and so forth, because if they don't keep up a certain number, they're going to kick. This stress is a big challenge to the immune system. It suppresses and depresses. Studies that Talbot and his group have done a number of studies, they showed that stressed individuals, again, more likely to get upper respiratory tract infections. In these studies, taking 250 milligrams a day had 10% fewer, as opposed to, or 10% over the period of 12 weeks, as opposed to almost 3 times as much, 29% using the placebo. Vaccinations. A lot of people are for them, a lot of people are against them. I'm not going to get into that. That's between you and your healthcare professional. Learn all you can about them. But the work shows that if you're going to do vaccines, you're going to get a better, again, immune response. It's not the vaccine that does the protecting, it is the immune system's response to the vaccine. Okay? The beta glucan is going to help that process, and the outcome's going to be better. They've looked at older people, again, that immune senescence. They've looked at younger people, different studies, both of them randomized controlled studies, both confirming one another. All these studies pointing the same direction. Immunosenescence, took me a long time to understand how that was pronounced, weakens, particularly on the innate side of the immune system. The receptor, it doesn't disappear, it doesn't go away. It's still on the cell surface. The beta glucan re-engages the pathways. And it's been shown that in our older populations, 50, 70, give or take, that is, I don't know why they discriminate against us, Dr. Jimmy. I don't know why they're afraid to give us older guys the dose. It's going to hurt us. No, not so. But we find that things like gamma interferon, very important, tends to be reduced in the older populations. Very, very important. Cold and flu season. Again, the Zong work, a meta-analysis, overall 65% reduction in the odds of getting it, and starting 3 to 4 weeks before the peak system. And to talk about cancer, the best way to beat cancer, don't get it. Best way not to deal with colds and flus and all that, don't get them. So get that loading done, get that trained immunity in play before the water comes floating in. The greatest benefit, you say, who can benefit the best? Guess what? The ones that need it the most. The people that are young and strong and bullets bounce off of them, what I do is invisible. They don't know what can come, but they live long enough, they'll find out. Next slide, please. This is a really pretty slide. It kind of covers a great deal of what we've talked about. Again, we've got the Dectin 1 receptor. And by the way, they figured out how to mathematically draw and crystallize this. And there's actually a place where you could go and actually see these colorful ribbons and whatnot showing where the beta glucan molecule binds. And if you zoom in, you can see the carbons and the hydrogens and the oxygen and what area that they bind. Boy, science is really cool. We need to know that we're getting a particulate form to get proper activation. Otherwise, the stuff just kind of floats out there and never land. Doesn't do a great job. That signal, this is giving you a pathway. Number 3, this is giving you a pathway, a map of where it goes, what it will influence. Again, Joyce Zopp's a cascade of immunological events, and then downstream, what comes out the other side. These very, very important cytokines. Number 4, complement and CR3, a way to execute the clearance, not only of cancer cells, not only important with our NK cells, but also our neutrophil population on any given day, 50, 60, maybe 70% of our total white blood count, and not do damage to our healthy cells. Again, reminding you, a particulate, a 1316, all of these things, the conformation, the molecular weight, uh, they don't work so well otherwise. So that kind of wraps it up. The right structure, the right form gives you the right mechanism, and therefore the right results for everybody. Next slide, please. We asked the question, and really the only one that matters, is it binding, and how well is it binding to that receptor? 30 years in this category, over 200 studies by Dr. Vetvika and other folks, but just to that one researcher, over a dozen uh, clinical trials in journals like Nature Immunology, all this third party validation. We're not telling you here a supplement category. We're talking about a receptor binding category. And I want to thank you for hopefully not falling asleep and bearing with me. But if you'd like to pose some questions, I'm happy to try to answer those questions. And if I don't know the answer, I promise not to make it up, but I promise I will get you the answer from somebody that really knows and understands.
Thank you, AJ. That was really, really fascinating.
I'm sorry, darling, you were a little bit muted in your response.
That's okay. Thank you so much, AJ. That I learned so much.
Well, I hope I gave everybody some pearl of wisdom so that you can share it again with people that you care about, family, loved ones, shirt tail relatives, somebody that owes you money. You want them to stick around a little bit longer and pay you back, right? So and there's so much more, darling. That this is just kind of a wetting your beak just a little bit. Uh, I
Now,
can go 3 days, and I got credentials to prove it, but not tonight. Not tonight.
okay, where in the body, where in the digestive tract is this actually working? Is it in this small intestine, or does it go and work in the colon as well? Or
Okay, so the particles go through the esophagus, go through the stomach, totally unchanged. When they hit the small intestine, they are just wet. They're same as in the
yeah,
capsule. They have not altered those particles at all. This is where you've got your villi, you've
uh-huh.
got your Peyer's patches, Peyers, and in those Peyer's patches, you have what are called M cells, microfold cells. And these are like, I compare them maybe to like Venus flytraps. They are physically, it's not an absorption like with so many food supplements, your vitamins and minerals and whatnot. The particle is still intact and grabbed and pulled through the lining of the small intestine. And that's where it then is found, first exposed primarily to macrophages. The macrophages say, oh, I know what that is. And they grab it, internalize it, they phagocytose it, and then inside the cell itself, and I don't want to use the term digest because it doesn't have the same kind of system as our digestive system, but it has the actually enzymes, reactive oxygen species, and so forth inside those cells that will break down the particle, large particles into small, kind of turn the rocks into BBs, the BBs into powder, and ultimately digest them, if I dare use that word, until they break it all the way down to a water soluble molecule steadily being secreted as those cells migrate through your lymph system, which of course parallels your bloodstream. So it doesn't just stay there in the intestine, but a lot of the work that's done in the intestine passes in. You've got your gut brain axis, a
Mhm.
huge amount of the immune system, therefore, the immune response comes from what's going on there in the gut. So we want to take care of that gut. You mentioned the gentleman doing so much of the microbiome. Another thing, this is a complex carbohydrate. It is itself a fiber. And so gut bugs tend to like fiber, a different kind of fiber, though, than what you find in Cheerios, a different kind of fiber than what you find in Metamucil or whatever these fiber compounds that people get. So it's healthy in a couple of different ways. Uh, it's not that we can't benefit from some of these other things, but I look at those other things as peripheral. My primary focus is what it does immunologically for you. These other things, that's just cool too. So does that give you a good picture on how it gets
Yeah,
gets
yeah, it
started?
does.
And then downstream, where the macrophages are passing off these microparticles and now water soluble molecules, this is giving rise into the CR3 receptor, its work, toll-like receptors, scavenger. There's a number of receptors, as you know, and our compound interacts with all of them. But that first one, the most important one, the Dectin 1. 30 years ago, we thought it was CR3. Science advances, science changed. Now we know we got a couple of different receptors. They do different things. They set off different cascades in the cells themselves, hence different cascades globally for the immune response.
Now, how about people who have immune-related diseases, lupus,
Okay, good,
rheumatoid diseases? How are
good,
they
good,
affected?
good question. There's three categories that I've always said we need to proceed with extreme caution. Uh, Autoimmune disorders,
Mhm.
transplants or grafts, uh, pregnancy. So let's kind of hit on those three. Particularly if you are taking prescribed medication to suppress and or depress the immune system,
Mhm.
I would say proceed with caution if at all. Now, over the years, have interacted with a lot of medical doctors with lupus, with a number of different types of autoimmune disorders, alopecia. Gosh, it must be 80 going on 100 autoimmune disorders. We know so much about the symptoms and still don't know exactly what causes them. That's okay. We want the doctor or the team working with that patient saying, okay, we're monitoring you anyway. We having you come in every 6 months. And I don't want to give a bunch of anecdotals, even though I got them, but I want to say in those three, be cautious. Be cautious because let's say a woman is pregnant. Uh, I had a medical doctor tell me one time I wouldn't recommend a glass of water to a pregnant woman because if something goes sideways, I'm going to get blamed. But yet they
Yeah.
give so many drugs and chemicals to induce pregnancy and to do whatever. The blood pressure goes up. We're going to do, I'm sorry. It's just that's an area I don't wish to be on that side should something go wrong.
Okay.
I would suggest that people be cautious. But uh, other than that, again, the window of safety. Now, is it possible for someone to have some sort of sensitivity or glucan? These are the things I hear sometimes. AJ, I took the product and I burped, and I had this kind of yucky, when I burped. I said, okay, tell me when you took it, how much did you take? How much water did you drink? Oh, well, I did just what you said. I put it on the nightstand right next to the bed, 4 ounces of water. I drink it, and I'm going to fix my breakfast, go take a shower and burp. I said, okay, let's do this. Go ahead and have your breakfast. And let's wait 30 minutes before you have lunch. Take the product. Again, we know that 72 hours, it doesn't matter if we take it morning, noon, or afternoon. We're going to get the immune response on a routine basis. Uh, if you need to take it with your tea, if you need to take it with your milkshake, your protein shake, or whatever, so be it. Somebody said, "Oh, I took the product and my bones ached." Well, how old are you? Well, I'm 73 years old. Uh, well, have your bones ever ached before you were taken away? Well, yeah, I'm seeing a chiropractor and I got advanced arthritis. And I said, well, I said, in all the clinical studies, high doses, long term chronic use, we don't see anything reported about bones. But again, I don't ignore those things. As you know, if somebody says something, we have to document it. But we respond, we explain, and then again, look, go see your medical doctor. Try to get a feel for why those bones are hurting. And that's an example of what somebody might say. I've had people come back and say, "Wow, I took the product and it gave me diarrhea." Okay, so tell me what you had to eat yesterday. Oh, I'm on a cleansing fast. I said, okay. I said, tell me about it. And you find out the diarrhea might just be coincidental to the same time that they were taking the product. But again, I don't discount it. I don't laugh and joke about it. I'll just, because if it's serious enough for them to pick up the phone or send me an email, it's serious to me, and I want to resolve. Uh, I can go on with different stories that I've heard over the years. A little old lady that said, I started taking your product here a couple of weeks ago, and all of a sudden my blood sugar shot up. And I said, well, do you have diabetes? Well, yes, I do. I said, well, the doctor's treating you. Yes, I've taken whatever units of insulin from time to time. I said, very good. I said, tell me what you had to eat yesterday. Well, I ate so and so, and I got this beautiful watermelon down at the down at the market, and I had a big old slice of that really ripe watermelon yesterday evening and the evening before and the evening. I said, well, that watermelon might have something to do with that blood sugar issue. So again, these are all anecdotals that prove to be inconsequential to the issue. But again, pregnancy, your grafts, your transplants, and people that have these autoimmune disorders underscore, particularly if they're taking the prednisones. There's different chemotherapies and so forth to try to shut down the immune system. That would be where I would back off and really, really get the team involved.
Okay. Well, very good. We've gone quite a while. So,
I'm
does anybody else
precious
have questions,
Daisy.
or are we ready to go?
Well, I'm so pride privileged to have your confidence to I hope I've entertained and hopefully raised the awareness level of what people knew
Oh,
about or
you
what they
certainly have,
didn't know.
AJ. I really appreciate you doing this.
My pleasure.
And I
I'm
have a
thrilled that you
feeling,
called on me.
uh, at least from the people here, you're likely to get calls asking questions. So,
Well,
uh,
just between me and you, all this stuff is written down inside things they call books,
okay.
where we keep it hidden from the public. But not everybody goes to the. Do they even have libraries anymore? You know, you and I used to go to the library and seek these books and go get them Xeroxed and all that sort of stuff. And I tell the young people that today, they said, well, I don't even know where a library, where I'd go. I
Yeah,
Google.
this big research campus, the North Carolina Research Campus, with labs from Duke University, UNC, and all about 8 different universities. They don't have a library.
That's a
Nobody
shame.
uses it. Everybody's doing it online.
Well, I guess they save a lot of money on paper. I don't know.
I was kind of like looking forward to when they were doing it. I said, oh, that place will have a great library I can go to. Turned out
Well,
that wasn't the case.
well, you and I remember when PubMed came
Yeah.
online, and that was a blessing to be able to sit there. But you've got to be pretty good to do the proper search on PubMed and immunology, genetics. These are things that are moving so rapidly. What I've done is I go to PubMed, and let's say I've got a search that I'm doing for the immune system. Well, PubMed actually has a tool where they will take my search, and if a new study comes up on the topic of immune system, it will send me an email and say, here's 3 studies. Now, I might not be interested in what beta glucan did with the European sea bass, but hey, here's a study on it.
Okay.
So, but that saves me doing a lot of work in
Yeah.
the meantime. So
Yeah, that's a good feature. I haven't used that,
yeah,
but maybe I can give
just
it a
go to the
try.
advanced search and it'll
Okay.
explain how you do that.
Okay, well, I will. Appreciate it, AJ.
Thank you all again so much. It has been my pleasure.
Thank you,
Thank you.
I've
AJ.
enjoyed it.
Thank you, sweetie. So good to see you. Bye
Yes,
bye.
sir. Bye.
Bye bye.